Welcome to the Real Python Podcast. This is episode 21. Do you want to learn the how and when of implementing k-means clustering in Python? Would you like to practice your Pandas skills with a real-world project? This week on the show, David Amos is back with another batch of PyCoder's weekly articles and projects. David talks about a Real Python article about how to perform k-means clustering in Python. We also talk about a new project-based article on the site about how to create a gradebook using Pandas, in which you'll practice the skills of importing, merging, and calculating across groups of data. We cover several other articles and projects from the Python community, including JPEG image decoding, object-oriented development with interfaces and mixins, sparking joy with Python, 5 package picks from real Python authors, and more. So let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David, good to talk to you again.
Yeah, great to be back.
I wanted to start off this week and talk about an article that is diving into kind of a topic I've been interested in for a while, which is JPEG and JPEG compression. It's by Yasub Khalid. It's on his blog called Understanding and Decoding a JPEG Image Using Python. And I'm a photographer. I've taken professional photos for, a few different eras of my life. Did some stuff for some music magazines, this magazine, Mix Magazine. I don't even know if they're still around, but I did some photography for them. And then used to do like other kinds of things on the side. So I was always kind of intrigued by it and always kind of wondered how the compression worked. And this really dives deep into it and then gives you tools in Python to not only, decode a JPEG compressed image and kind of see what's going on in there, but it goes deep into the whole process of what's happening when something's being encoded and the whole kind of lossiness of JPEGs, which I thought was really neat. It kind of goes into this whole idea of what gets lost. One of the first things that's really, I think, interesting is that the JPEG color space, and I didn't know this right away, which is in yxcvbn, which is the Y being for luminance, which is kind of like the level of brightness or kind of like the overall grayscale of everything. And then there's a CR and a CB, CR being the chrominance red and the chrominance blue. So the kind of the color levels of red and blue. And so that already is kind of changing the overall look of the image from RGB into this other space. And that's where they can kind of get into this whole idea of like, okay, what can a human tell, as far as differences? And so there's a lot of information that can kind of get sort of simplified there, if you will, to maybe allow for reducing this file size. And then it kind of breaks everything into these 8x8 pixel sort of chunks. And then they apply this thing called DCT, which I was not familiar with at all, which is called discrete cosine transform. In that process, it looks at, of that 8x8, what is the overall balance of all those YCRCB images? And there's an overall initial upper left corner of this process that is saying basically 1 or a 0, kind of like an overall black or white. They call it DC. And then all the other ones are kind of alternating, very cosine shaped waves of, okay, where the pixels kind of overlap. And then each one of these, as it goes along, this 8x8 thing is determining, how complex of a combination of all these cosine shapes make up this pattern inside the 8x8. And it's really fascinating to me, like, how they could do that and how it kind of translates. And there's a really good YouTube video that's linked in there that kind of shows you how that works. And then after that's done, it kind of goes through like this zigzag pattern of determining from that upper left corner of the overall, like, dark light to these other values. It goes through and basically creates a pattern across the 64 squares of like, okay, well, how much of this information is going to be used? And then from there, it can be quantized. And there's like a quantization tables that are saved in there for sort of rounding down things, because the levels are going to start to approach like 0 near the end of that. And so one of the things you can do with that to reduce some of the data is these types of compression. And there's like 3 of them that can happen, which is one called run length, where let's say, the first 10, 12 squares you look at have actually pretty high values in it. But by the end of it, once it gets quantized down, it's, basically all zeros. And so that there might be like 50 zeros then. So that's very easy to compress. You say, okay, repeat 0 50 times or something like that, which is this idea of like run length compression.
Yeah.
And then there can be like another form, which is called delta encoding, where it's just basically changes. And then it gets into this other idea of something called Huffman encoding, which is, they include another link to another video that kind of explains that. But this is like in the 50s, David Huffman figured out a way to compress language down using these binary trees, and doing kind of a similar idea with the colors here of like, these are the only values that are being used. And so anyway, all that information actually gets stored into the compressed file then, with tables of that information. Like, okay, what's the Huffman tree look like to re-encode or decode this? And the same thing with, how the thing was quantized. And that's, I think, why JPEG images can fail pretty spectacularly, is if one of those pieces of information is wrong, or 1 or 2 bits of that type of information, you start to really have disastrous results in decoding it. But the Python part of it goes into this whole idea of like going through the reverse of that, and all the data is in the file, and goes through showing you, the zigzag pattern of reassembling it, reading from the Huffman tables, reading from the quantization tables. And I don't know, it's just a really neat exercise. And if you're interested in images, and then images in Python, I think it's a really kind of a cool way to dive in and learn a little bit more about not only JPEGs, but, image encoding, and how that might be translated through a Python library. And so got a whole GitHub repository with the code and links to prior work by other people that have been kind of playing around in this field.
Yeah. And this actually ties into an article we talked about several weeks ago now, that was called How to Trick a Neural Network.
Yeah.
You remember that?
Yeah.
Where we had there was like a neural network that would classify images, and there was a way to trick it into thinking that an image of a corgi was actually an image of a goldfish.
Yeah, exactly.
And the way that they defend against that was by using JPEG compression, actually.
Oh, okay.
To remove some of the like adversarial information, the noise that caused it to trick the neural network. So if you saw that, or if you heard us talk about that article and want to get more background on JPEGs and compression and everything, then I think this is a good follow-up to that one.
Yeah. It's a fun way to, dive into all those kind of topics together. And
yeah, totally.
I forgot that was the way that they were helping to defeat that.
Yeah.
that stuff. So it makes sense, because there's a lot of information that gets thrown out, and a lot of the information could be in that, in these higher levels of light and color that, again, the eye has a hard time seeing the differences in. So
right. Yeah.
But a computer would. So
right. And could potentially fool it into not really knowing what that image is, right? It's
right.
You can encode a lot in there. So yeah.
All right. So what you got first?
Well, the first one that I've got is an article from Real Python by an author that this is his first article written for Real Python, and I think he'll be doing a lot more for us. His name is Kevin Arvey, or Arvey. I'm not sure how he pronounces that. The article is called K-Means Clustering in Python, a Practical Guide. And this is for the data science folks. It's about clustering algorithms for classification. And in particular, this article is about the K-means clustering algorithm. It talks about what K-means clustering is, when you would use K-means clustering to analyze your data, how you can implement it using the scikit-learn package in Python, and then also some tips and tricks to help you optimize the algorithm and select like a meaningful number of these clusters in it. So yeah, just a great overview of that algorithm and how you can use it. A couple of things I like about the article is he kind of puts this K-means clustering idea into context and compares and contrasts it to a couple of different types of clustering algorithms. So he talks about partitional clustering and hierarchical clustering and density-based clustering, and how all these kind of how the k-means sort of fits into all these different types of clustering algorithms. So basically, the idea behind k-means really is that you've got a bunch of data points and you're trying to assign some labels to the different points in the data set.
To sort of categorize them somewhat, right?
Right, exactly. Some categorizing them as some, something. And so it could be anything, right? I mean, maybe your points represent, I don't know, some kind of label it as some sort of animal or something. Or it could be maybe a type of cancer. Maybe it's like you've got a bunch of data points from like a cell biopsy or something, and you're trying to label certain data points as like cancerous cells or non-cancerous, or maybe even identify the type of cancer. There's all sorts of applications, but the cancer one comes up in the article, which is why I'm talking about that.
Okay.
But sort of the idea is you've got these groups of data points that you can plot out, and you can start to kind of group them together and calculate what would be considered like the centroid of a group. And you can iterate on this process to get a tighter, like a hopefully a better fit of like, here's all the points that are kind of close to this centroid and all the points that are close to this centroid and all the points. And that would help you then label the different data points with whatever you're trying to label them as. So he walks you through setting up an entire scikit-learn pipeline to like an end-to-end pipeline that trains a model on a data set, tests it and everything, and then gives you the final model that you can use to run the k-means algorithm. So yeah, it's really in-depth, lots of great examples. In fact, he's even got a great example of where k-means can go wrong and where it like isn't the right tool for that particular data set. So there's just a lot of great information here to help you understand what that algorithm is, how you use it, how to apply it, and how to build it in Python.
I played around with this in scikit-learn and a little bit of k-means stuff, and so I learned about the elbow and trying to figure out like what's an actual good number of
right
groups to divide things in, because it becomes less sort of meaningful going beyond or above a certain amount. It was the information I was playing around with was shopping information.
Okay.
And so it was kind of more like a retail environment and trying to figure out like, sort of retargeting marketing stuff. And it was very useful. And it was a useful tool for that. And you could really see, again, visually kind of what's happening with it using matplotlib or something like that to start to kind of map out some of these ideas of like, okay, well, where are all these things kind of appearing? Sounds like a cool project. I'm excited to have more data science stuff happening on the site.
Yeah.
My next one is actually a real Python one myself. It's a Pandas project. So it's a very project-based article with lots of data in it ready for you to kind of play around with. It's by Brian Weber, and it's called Make a Gradebook with Python and Pandas. And in it, you get kind of a quick demo of like what you're going to be building. But the overall idea is if you are interested, in how to aggregate data, merge data, combine data, and use pandas for this whole process, it takes you through that whole idea. In this case, the example is truly doing actual grades. You kind of initially explore the data, and then you need to go through the process of using Panda to load in the information, and involves like a roster and then unique IDs to connect to different homework files, exam files, and then quiz files. And then you start merging, based on different indexes, filling in nan, not a number, values, the sort of NumPy stuff there. And then eventually getting into calculating grades and creating formulas to do that stuff. And it's pretty slick. I went through the whole thing kind of playing around with it, and I decided to use a Jupyter notebook in this case, just to kind of be able to keep looking at some of the data as I work through it. And I might suggest that as a way of kind of playing with it yourself as you kind of start to continue to build this project up. And then, maybe eventually turn in standalone scripts from there. But that was a nice way to kind of see some of the stuff as you were working on it.
Yeah.
Get into plotting at the very end, summary statistics, and you do little additional data science stuff right in there, kind of doing a little bit of calculations and figuring out means and kind of overall grade curves.
Right. Yeah. Yeah. He compares it to like it shows the histogram of the grades for the distribution of grades in the class, and compares it to the normal distribution, which I think a lot of teachers are probably familiar with this process, to kind of see like
Exactly. Yeah.
Yeah.
And then, kind of goes into a little bit of like, different ways to divide things up into separate groups if you want, ways to assign something categorically like a letter grade. And if you wanted to weight things one way or another. And it's a neat project. So I don't think you necessarily have to be a teacher to appreciate kind of the things that are happening in it. I think it's a good project that you could modify into
Yeah, for sure.
lots of other things where you're kind of building up information. It just gives you some nice methodologies for doing all of it as a project.
Yeah, it's a good application of pandas to like a real world problem, right? And I think Brian is actually a teacher. I think this is based on the system that he actually uses
That's cool.
in the real world to sort of automate all this work that he has to do at the end of each semester. Yeah, it is. It's really cool.
Some real earned experience there.
Yeah, totally. While you were reading this, did you sort of notice any differences between this article and other articles on Real Python?
I feel like it has a little more of a step-by-step sort of flair to it, which I felt was a little different.
Yeah.
And that's why I felt like it worked really great for the Jupyter Notebook thing, where I could take the chunks of code and paste them in and just sort of, keep building on what I had. And so in this case, I was able just to kind of almost just like, it felt a little different. I kind of liked it.
Yeah. So this was kind of a beta version of a new style that we're working on of tutorial, which are these project based tutorials that are meant to be more, like you said, like just a step by step process to walk you through, building a project from start to finish, as opposed to an article that's more focused on sort of teaching you the concepts.
Yeah.
And that kind of thing. So yeah, that's you hit the nail right on the head with the step by step there. And I like to think of these sort of as almost like Lego instructions.
Okay.
Right. Where it's like, instead of showing you like why the pieces fit together the way they do, or why certain design decisions were made, it's just, well, first you do this, and then you do this, and then you do this, and eventually you get this this whole project out of it. So they're meant to be kind of supplemental to the other kinds of articles that we have that are more teaching focused.
Right.
And this would be something like, if you've read, and I think even at the beginning of the article, he's got this background reading section where he lists, I guess 5 different articles that would be like good prerequisites to reading this. And then, okay, now you understand how to use pandas, how to do some basic operations with data frames and things like that. Now let's apply it to a real world project.
Yeah, it's slick.
Yeah, so we'll be having more of those come out. So
cool. Yeah, it'd be good to get some feedback on it.
Yeah, exactly. For listeners, if you like this, or if you have feedback for us on this style of article, we're all ears.
Yeah, I want to know. This week, I want to shine a spotlight on another Real Python video course. The course fits in with some additional techniques for working with the Pandas project. It's titled Reading and Writing CSV Files. The course is based on a Real Python article by previous guest John Fincher. And in the course, instructor Joe Tatasco takes you through what makes up a CSV file, reading and writing files using Python's CSV module, advanced CSV reader parameters, and how to read and write CSVs using Pandas. I think it's a worthy investment of your time to learn how to wrangle CSV files using Python, whether it's for big or small data projects. And like most of the video courses on Real Python, the course is broken into easily consumable sections, and you get code examples for the techniques shown. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. So what you got next?
Well, the next one I've got is, well, make sure I get the name right here, Redouan Nafi. I think he goes just by Red,
okay,
as a shorthand here, but we featured lots of his articles on PyCoders. This is one of his newer ones. It's from the beginning of July, but it's called Interfaces, Mixins, and Building Powerful Custom Data Structures in Python. So this is all about the idea of like an interface, an abstract base class. So it's, sort of some higher level OOP concepts.
Yeah. All that whole object oriented level stuff. Yeah.
Yeah. Which is, it's one of those things that there's a lot of people that sort of shy away from this kind of stuff, or say like, don't jump into it head first, but there's also a lot of reasons that you would use these kinds of tools, especially on, larger projects, and depending on maybe if it's a a library that you're trying to provide tools for other developers to use to create their own project. So it's good stuff to be aware of, especially if you are kind of already a fan of the OOP, or if you just want to know how, like, the frameworks and stuff that you use. So the frameworks are big projects where you see these kinds of patterns being used, like Django or the Django REST framework and these kinds of things. So he talks about the focus is interfaces and mixins. And so he talks about, interfaces are sort of like blueprints for classes, which I think a lot of people maybe hear classes being described as blueprints for objects. And so you've got, what's a blueprint of a blueprint, right? It's seems kind of strange.
Yeah.
Basically, interface defines certain kinds of methods that should be on a class without actually implementing those classes. So it's like a parent class that you would then use to create child classes that inherit from it. They would then use to create like different kinds of objects, right? Based on a similar kind of parent class. So an example might be, maybe you have like an automobile class, and then that's like sort of your interface, provides like the different kinds of methods you should have on an automobile. Like maybe there's a drive method, or a refill gas tank method, or these kinds of things that all automobiles are gonna have.
Right.
And then from there you might create like a car child class, or a truck child class, or a I don't know, 18-wheeler child class, or something like that, to create different kinds of objects. So he talks about that there's two different kinds of interfaces: informal and formal. The main difference being that an informal interface doesn't like enforce like that the methods actually have to exist on the child class, whereas a formal one does. So for example, in that automobile thing, you might just have like, define your class automobile and say, okay, it needs to have a drive method that an argument or a parameter called distance or direction or something. Maybe so two parameters like distance and direction.
Sure.
And then it doesn't actually do anything. That would raise like a not implemented error, or return not implemented, or something along these lines. And then you would inherit from that automobile, and then you would actually implement that drive method. But if you were to like create an instance of this automobile class, you would be able to do that. There'd be nothing stopping you from just creating an automobile instance. And then if you try to call the drive method, you would get this not implemented error when you tried to do that. So you wouldn't be told off the bat, like when you tried to create the automobile instance, that, hey, you need to implement this drive method, otherwise you can't actually use this thing. So that's an informal interface. A formal interface would actually enforce this. So if you tried to create the automobile instance, as soon as you tried to create it, you would get an error saying you can't create this object. You have to implement this drive method before you can do so. And so the way that you do that is you would inherit from this capital A, capital B, capital C, ABC class, which is from the lowercase ABC module in the standard library. The ABC stands for abstract base class. And in that same module, there's an abstract method decorator that you use on all of the different methods in the interface that says that, okay, this is an abstract method, meaning it doesn't actually implement anything. It's just like providing the name and signature of this method. But when you have all that in place, then if you were to try to actually instantiate the class, or instantiate an object from the class, then you would get an error saying that you need to implement these abstract methods before you can do anything with it. Kind of two different approaches there.
I could think of that like extrapolating on your idea there. If you had this overall class automobile, and you have an abstract based class, or you have this method part of that that's simply like refuel, but it doesn't necessarily specify, like you said, what that actually is implying. When you go to actually create the actual class, if one of them is like an electric car, the refuel could be
right
via like a battery method, whereas another one might be actually using gasoline if it's like a gas based car.
Right.
Okay, so that just you're not determining it early on up there. It's just it's something that has to be implemented though.
Right. It's defining like the API, right, for what an automobile should have. Like they should all have a refuel method. They should all have a drive method. They should all have
right.
What the actual implementation of those is depends on what kind of automobile it is.
Right.
But they should all have that interface. So you can kind of boil it down like the difference between interfaces and these things called abstract base classes. So an abstract base class is like a more general version of an interface. So an abstract base class can have concrete methods, which are like they actually are implemented and do something. It can also have like internal state. So it can have attributes, keep track of the state of something. An interface is an like a type of abstract base class that doesn't have any internal state and has no concrete methods. All of its methods are abstract methods, which are
Okay.
don't have any implementation and would generally raise a not implemented error if you tried to actually call that method that wasn't implemented. And then he gets into talking about mixins, which are another type of abstract base class that are classes that are not intended to be instantiated. They can have both abstract and concrete methods. So they're basically a special kind of abstract base class that doesn't have any internal state.
Yeah.
So it's a subtle difference. But mixins are really meant to like, you can almost think of them as like partial classes as kind of it's a really loose way of thinking about it.
My favorite way that I saw this being used was when I got into visualizations, and a variety of them. This is, how they were described in the APIs were like, okay, this particular visualization is for doing dots as opposed to bars or something like that. So those dots could have this whole set of mixins that, okay, is this going to implement having a name on that object, the size of the object, the color of the object, and so forth. And so it allowed for this flexibility in this whole library of different types of charting and graph type of abilities that they could just add the mix in. So it's like, okay, this one's going to have two axes, and those axes need to have labels and all these kinds of things. And so you could kind of see the structural thing where you're sort of, I don't know, plugging in the additional components to this type of chart. It's like this chart should have this set of features because it's, designed for lines and it's 2-dimensional versus like ones that would be 3-dimensional would have different ones. And so it allowed this sort of flexibility where you're not going to instantiate just an object that is just the mixin, which would just be like an axis, sitting there by itself. It needs to be part of this class that is the overall chart, class or whatever. I don't know if I'm explaining that well, but that's how I've seen it.
Exactly. I mean, I think of it too, like another classic example, I think, is like in the Django framework, where you have like a class-based view. So if you're familiar with Django, you might define a view in your web application using a class, and that they have different mixins that would sort of bring in different kinds of functionality or things into that. And so they've got stuff like that, that it should require authentication, or it should require certain kinds of permissions, or that it should be like a template response versus like a different, like a JSON response or something like that. So there's all these different mixins that you can use so you have like multiple inheritance going on. You have your view that's inheriting from these different parent classes, which are these mixins that all sort of bring in different kinds of functionality in there. Yeah.
So it looks really interesting, right? So you're like defining that new class, and then you'll have like the base class that is supposed to be, created on, then comma, and then all these additional ones sort of sitting after it, right?
Right. Yeah, exactly. Yeah. And it can get large too. Like sometimes if you need to have lots of different things. But anyways, this article by Red does a really good job of just sort of breaking down like what all these different things are and what the differences are. And he's also got a nice overview differences between interfaces, abstract classes, and mixins. So to kind of keep track of like what the subtle differences are between, because they're all very similar in ways, but there's nothing like, really, it's just how these things are meant to be used. I mean, it was what it really boils down to. Like, it's really like, there's nothing that like really defines, like you say, like, oh, this is a mixin, and there's some, I don't know, something that like makes it a mixin in your code. It's like, well, no, a mixin is just how this thing is being used, and sort of like the properties that it has. But he goes through, like, he gives you a concrete example, and then talks about how to use all these different ideas to create some like powerful custom data structures. And one of the things that's kind of neat is he goes into how you would create like a special kind of dictionary, a custom dictionary that interfaces with SQL Alchemy to actually store keys and values in a SQL Alchemy compatible database, so that you've got like a dictionary basically that's actually persisting its data to a database somewhere, and all you're just using it like you would like a normal dictionary. So he kind of goes, he calls it going ballistic with all this stuff into like this kind of crazy idea, but it really highlights like the power of all this stuff, how you can really create some like interesting kinds of data structures and everything that has lots of different kinds of functionality. So whether or not you would actually do this in practice, I guess would kind of be up to you or depend on your project, but it does show you how, the real power behind all this stuff.
Yeah, that's what's always kind of cool about reading about these kinds of things, and keeping your finger to the wind, and like, what are all these things that are available to me as a problem solver, like
Yeah.
ways that you can try to accomplish stuff, because it's easy to paint yourself into a corner as a programmer to not have a plan and just simply keep working in a direction, then suddenly you're like,
Right.
oh no, I need to rethink this whole thing. So this idea of like being able to mix stuff in, or think about the structures of stuff. We've talked about video games before on the podcast, but that's an area where I think of object oriented really need to think about like, what are these things going to be able to do, and so forth. And so when people think of like adding changes to to your code, like I guess working with a team, that's where it can get really kind of crazy like that too. Where like suddenly, well, you're just adding one feature. And it's like, no, you don't understand.
Yeah.
I have to restructure everything to make that work.
Right. Yeah. Also, just a shout out to Red. Thanks for in his references here on his article, he links to implementing an interface in Python, which is a real Python article by William Murphy.
Yeah.
From back in February of this year. So, and then he's also got some other great references. There's here's a Mixins for Fun and Profit, which is on Dane Hillard's, who's another real Python author.
Yeah, I hope to have him as a guest soon.
Yeah. And a link to, I guess, a video by Raymond Hettinger about called Build Powerful New Data Structures with Python's Abstract Base Classes. And Raymond's a fantastic teacher. I learned a lot from watching his YouTube videos. So, lots of good references there in Red's article as well.
Cool.
What do you got next?
My next one is, it's kind of funny. I think the idea of it is based around Marie Kondo and the idea of, sparking joy. It's by a guy named Maxwell Forbes, and it's called Sparking Joy with Python. Has a picture of her on there at like a conference talking. You ever watch that show?
No, but
what's it called? Tidying Up or something like that?
Yeah, I don't know.
Yeah, the Marie Kondo method. I watched like 2 episodes of it. I just couldn't handle the people. I think the topics are good, but that's my whole problem with like reality programming in general. It's just like, especially when it can be couples, and the couples, like, maybe they don't really like each other. It just I don't need to get into that world that close,
Well, I'm sure they found like the most extreme examples of like orders and things like that for dramatic effect. So
right. So they can see a difference.
Yeah.
But to me, it's just like I get anxious watching it. Anyway, I think the idea was that, so Maxwell, he started out in Python, does a lot of data science and natural language processing sort of research.
Mm-hmm.
And then took a while and did like a side project creating a video game. And he created this game, and in that process, he was using TypeScript, which is something we've talked about a couple times in the podcast. I talked with Armin and a few different people, but TypeScript's like JavaScript, but it adds static typing in a lot of ways to what you can do in JavaScript. And it's very popular, and he really became this big fan of it, and really felt like these are some of the things that he felt was missing in Python. But also along with that, he really loved the whole cycle of creating a video game. The idea of like, you make a change and then you can just see that change on the screen, and the interaction and stuff like that. And I understand that process too. That excites me. I think partly why I'm like into the whole creative arts and stuff like that, music and audio and all these other kinds of things. I really kind of dig that part of it. And his problem was that he kind of didn't feel very joyful, if you will, working in Python. And he tried to figure out like, well, why and what are some of the things that he could apply to this. And so it's like a 4-part series kind of diving into that. And I think a lot of it's kind of a mix of things. Part of it was, again, static typing. When you're doing stuff inside of Python, especially as you work for a long time on a project and end up with lots of different files, as you start to work with them, if you haven't documented things well, which is a whole thing in of itself of going through and writing like long doc strings to explain what stuff's supposed to expect and what it's supposed to return and so forth. If you haven't done that, and then you go back and look at, say a definition of a function, and you have no idea what those parameters are supposed to be, and can be kind of frustrating to have to dive back and back and back and so forth into it. And so that's partly why somebody might get into static type checking or adding a little bit of that to Python by doing type annotations, which
Right.
I did a whole video course on one of Geir Arne's articles about type checking and talking about MyPy and that project of sort of adding that stuff to it. Because in the end of the day, Python is a dynamic language, and so the types are not enforced at runtime. What this MyPy project will do is look through your code and try to confirm what all these things are. And you have these simple annotations into, and they can be actually not so simple. They can be a little more complex depending on things that we were just talking about, like advanced data classes and things like that.
Mm-hmm.
But generally, you could say this is supposed to be an int, and this is supposed to be a string, and this is supposed to be a list with these types of other objects that are inside of it, and give yourself an idea of what it's supposed to be. And in some ways, I feel like that can reduce a lot of all the writing that you would do inside of, say, a doc string, and all the comments that you might need to add to it. And then you get this advantage of running something like this tool, MyPy, to say, well, it was expecting a string here and you gave it this, and you would actually start to see some of that.
Right.
And so, it kind of goes through a little bit of that, like, it avoids common mistakes. It can avoid often what he was running into, which was like typos and things like that. And he just had a whole bunch of little other additional things along with type checking that could necessarily maybe spark some joy and get rid of some of the frustrations. And one of them was using an IDE, which I am a huge fan of, and I use a VS Code. I don't know if I've ever asked you, what do you use for an editor?
I use VS Code.
I do. Okay.
Yeah.
And I played around with one that doesn't provide as much feedback. I played with like Sublime, more of a text editor kind of style thing. And I like the code suggestions. I haven't tried Pylance yet, though. That's something I think we'll probably look at coming on the show talking about.
Yeah.
And, the idea that it can kind of help you and highlight, and it's very modular. It can add sort of the Git functionality to what you have there, which I think is really nice. But then going beyond the IDE, structuring your code, having a tool, which we had Wukas on to talk about Black.
Yeah.
And the idea of like, okay, having a code formatter and not having to worry about like, how stuff's formatted. It's going to be formatted this one way, which I think is a really powerful thing to sort of take off the table. I know that can be, we've talked about it for teams to not have that be part of the whole code review process, but also to have it for yourself and your own code review, and hopefully that can help you avoid common things that you might do there. But then it gets into debugging using a REPL, which I do a lot in my tutorials. I use this thing called bpython, and I think it's really useful to be able to kind of see your code running. Garana talked about using IPython.
Yeah, I like IPython a lot.
Yeah. And so those are great tools to kind of check to make sure stuff's running instead of always having to go all the way, to the end of the project to finally see if stuff's working properly. And then, he talks about, just overall structure, structuring your code, importing things in order, starting with like your standard library and then third party and then internal project kind of tools as you're importing, putting everything in functions, avoid defining things outside in the top level of your file, that maybe you should put those things inside of main, like if you're like doing some initial variables or something like that you're setting up. And then just always adding, at least minimal comments so that you can kind of find things. And that's why the type annotations might be able to speed up some of that too for yourself. And I agree with most of these things. It's an interesting article because he kind of bounces around a lot.
Yeah.
And you can kind of see it was like kind of like a bit of a brain dump of like all these ideas of, like ways that I think could help people feel about it. But I think it's if you're feeling frustrated in your coding and you're feeling frustrated in your tools and your setup, it's like, yeah, okay, like that might be stuff to think about. Of course, you can fetishize that, and it could be like the whole thing, like like I've made this perfect code editor, and I got the theme and all the stuff installed and so forth. What have you created? Well, I got my code editor all set up, and you know get to that whole point where you're spending more time collecting the tools than building anything.
Yeah. I mean, I think everyone kind of goes through that a little bit at different intervals in their
Yeah.
journey, right? But I think the idea is, once you kind of settle on a workflow and sort of automate some of that stuff, then it's really you kind of, it does add joy in a way,
Yeah.
because it's like, well, okay, I've thought it through, I found something that works, and now I can very quickly get started on a new project because I've got some scripts that I created that sort of automate like environment setup and everything, and I've got my editor sort of fine tuned to the way that I need it, and it becomes a lot easier just to get started on a project and to look at your code and everything. And so, yeah, I mean, I think I really liked the idea in this article, or this series of articles. Really, it's like four
Yeah.
four
Four
articles
parts.
together. But by stepping away from Python for a little bit, he rediscovered sort of the joy of programming,
Yeah.
and then went back and found ways to bring that back into Python as well, which I just thought was kind of neat. And I think as developers, we shouldn't be scared of trying different technologies
Oh yeah.
and stepping out of our comfort zone a little bit, and we might find things that, which I think for this person, it really kind of feels like the whole idea of static types was like a big thing for him, right? Like he got into TypeScript and thought, oh my gosh, like this
Yeah.
this really makes a huge difference for me.
These rules are helpful. Yeah.
And that MyPy and typing are not that new in Python. I mean, there's been big changes recently and some of that stuff. I mean, if you go back to like Python 3.5 or prior to that, I think, I forget exactly when the type annotations became a thing, but there was a period where you could only do it with like comments.
Yeah. Just hints kind of in there. Yeah.
These type, yeah. So there's been a lot of sort of development over the past couple of years in the way that the way that types work in Python, but not the way that types work, the way that type annotations and type hinting and all that stuff works. But
I think part of that too is that as you look at other people's code and you want to implement that code in your project, very often you can get lost as to what's happening. What is this thing expecting and so forth. And so that again, when the project becomes more public and you're sharing it out there, that's where the annotations and all those things really
yeah,
are very important. He talks about that briefly too, like like just being able to like how am I supposed to interface with this thing? In something like TypeScript, it's
right,
very blatant, and right away what's happening. So
yeah, good stuff.
yeah, cool. So what you got next?
Next one I've got is another Real Python article that just came out this past week, actually, I believe, or the week before.
All right.
And July 22nd is when this was published. It's called Python Packages 5 Real Python Favorites. And this is another kind of new format for us. It's a roundtable article. We got together 5 authors and asked them what their favorite package is in the Python ecosystem that maybe replaces like something in the standard library.
Yeah.
To offer like better or different functionality. The 5 that we got here, we got Christopher Trudeau, who has, I think, mainly done video courses for us, but has sort of been...
He's done a couple. He did a Django article.
Yes.
Also.
Yeah. He's been doing more and more written content for us as well. So he's kind of crossed over and is doing both of those formats for us. He talks about the PUDB visual debugger, which is a replacement for the PDB debugger that ships with Python. It's inspired by GDB, which is like a visual debugger for not for Python. Oh, it works with like C, C++, Pascal, Fortran,
Oh my
those
gosh.
kinds of languages. Yeah.
It's a GNU debugger.
Yeah, it's the GNU debugger. But PUDB is a textual user interface. It opens up it kind of like something like Vim, right? Like as like an editor, but it's got some colors and everything. If your terminal supports all of that, it's got colors and everything, and you can see your code and you can see where breakpoints are set, and you can see like what the variables are that are set right now, and you can look into the stack, and then you all still have access to your command line, so you can run different commands and stuff. But it's a much more full featured debugger than just PDB, which is like super minimal.
Yeah.
It all takes place in the terminal. You don't actually need a graphical user. There's no graphical user interface. So this will run like if you're just SSHing into a system. If you have access to the internet and can get PUDB installed on it, then you can use this there, which is a huge benefit. So that's a cool project. We've got Martin Bruce with the request module. Most people probably know what request is, but he sort of mentioned some of the things that he likes about it, as opposed to using something like URLlib in the standard library. So he likes that request is readable. He likes that request is powerful, which I think you could argue that URLlib is also powerful, but URLlib is a lot more like low level, right? Whereas request is a little bit more high level. It's sort of lots of things go on in the background. It has a really nice, I think it's widely known for having a nice API and that. So it's that's Martin's pick there, requests. Gerana, his pick is the parse module, which is it's sort of a replacement of regular expressions, although I shouldn't say it's a replacement, because I think it's being driven by regular expressions in the background, but it gives you a whole new way of working with and parsing text that almost feels magical, honestly, when you when you look at it and use it for the first time. It's really powerful and really incredible. So just to give you an example, and the example that Garana gives is he takes the text of PEP 498, imports that in has that in as a string, and uses this search function from the parse library that you pass it like a string that almost looks like an F string syntax, but without the F,
the layout,
or like a format string.
Yeah.
Right.
Like we talked about last time.
Where you've got the curly braces, and the curly braces represent like what you're looking for. Like something would go here. Instead of having to do this like complicated regular expression pattern, the string he's got is like author, :space, and then curly braces, and then new line character, \n. So you pass that into the first argument for the search function, and then the second argument is the string that you want to search for this pattern in. And the result, it finds the name of it finds whatever would, like, if it finds a match for that, it returns like whatever would go inside of those curly braces that in the inside of the match. So it's just a like way more natural way of doing that. It really feels magical. And he talks about some other features about how you can use format specifiers in these things.
I could see this being really helpful for a topic we've hit a couple times, which is web scraping.
Oh, absolutely. Yeah.
The
next author is Brian Weber, who we talked about his Pandas article earlier on this episode, but he mentions the dateutil package, which is a much more powerful sort of replacement for just like the datetime package in the standard library, particularly when you need to work with things like time zones. Dateutil has a lot of built-in functionality for that kind of stuff. Also, really nice tools for parsing date and time strings that, again, also feel sort of magical. For example, the parse function, dateutil has a parser module in the package, and in the parser module, there's a parse function. He gives the example of just passing it a string that says Monday, May 4th, like 4th at 8 a.m. So this is all written out, and that function returns a datetime object, the right month, the right day, the right time, And because there was no year given in the string, it finds the closest match, which would be, at the time this article was written, 2020. So it can just infer the date, or infer the year for you. Like, they didn't specify it, so probably they meant the most recent one there, which is pretty amazing. This parse method is just a really neat way to parse those strings and get the datetime without having to use the format specifiers and remember the little string date formatting language that no one can ever remember off the top of their heads. The next one is Dane Hillard, who we also mentioned previously, and his pick is the Typer package for creating command line interfaces off of, going back to types, using type annotations to sort of automatically
Right.
generate help strings and automatically validate input and everything. So this is sort of a replacement for the argparse module, which is a great built-in module for creating command line interfaces for a program, but does require a lot of setup and everything. So Typer can be used to sort of make all that a lot easier and leverage type hints.
Okay.
Do some stuff automatically for you as well. So definitely a cool package to check out.
Wow, it's like a ton of information, like 5 little mini tutorials in one. Kind of diving, not super deep, but enough that you could like kind of get a little bit of information. Then there's like all the links that kind of expand on top of there for further reading,
Right.
so which is nice.
Yeah, you get a nice little taste of each package, but it's not.
Yeah,
I would say it's not any longer than a typical real Python article. So yeah, it's nothing goes into a whole lot of depth. But yeah, it was a really cool format. It was fun. I did the technical review for this one, and it was fun kind of getting to work with 5 authors at the same time. So just also,
did you put fun in quotes at that point?
Well, I do have to say, the person who's not been mentioned here is Alex Ronquillo, which sort of managed this whole thing. So he's
he's like the project manager,
like the project manager for this article. Yeah, he wrote like the introduction and I think conclusion for all of this, and managed all the authors and everything. So I just would sort of provide my feedback, and then Alex sort of handled making sure that the author responded to the feedback and everything.
Yeah, cool.
Yeah, good stuff.
So kind of moving into the next segment here, talk about projects again. I have a project that kind of goes into the security realm that we've been kind of dancing around a little bit here and there with our last couple episodes. The project is zxcvbn, that's all together, -python. So zxcvbn-python. And it's by Daniel Wolf, and it's basically based upon the code of Dropbox or Dropbox's realistic password strength estimator. And I think it's really handy to be able to get an idea of like what makes a good password. I'm sure people have in the past said, oh, just, make sure that you're, using a certain length or certain characters and so forth. This actually goes into and shows you in code when you're running this thing. If you give it a password and apply this to it, it'll tell you like how long it would take, depending on the type of hashing it would take to crack a particular password. It has an actual like crack time display. And so I did a couple of really simple ones where I just like used, like first name, last name, and then like 1, 2, 3 or something like that. And it said would take less than a minute, or actually less than a second in the fastest hashing to be able to crack that one.
Wow.
And then, depending on if it had to do it over, like an online with throttling or not throttling, it would take like 3 hours. And then, changing from that. And then it tells you like, okay, it gives it a score of 1 to 4 as far as like the quality of it. And then it says like how it would have tried to guess that. And it'll say, oh, okay, well, that's actually a dictionary word that's in the dictionary. Or it might even say, well, that's a male's name. So it came from the, that dictionary. It will know if, it'll guess the variations of like, oh, there was an uppercase letter, or there, or it was in reverse. And so it knows to, even if you were thinking you're being clever about like spelling words backwards or something like that. And so it pretty quickly shows you the types of things that will make a huge difference.
Mm-hmm.
And the first is just not using dictionary words, words that that something can go through and just look for in again, names and common words. And then, if you use like the really bad ones of like using password or sequences of characters like 1, 2, 3, or I've seen people type across the top letters of the QWERTY keyboard or something like that, and just shake your head.
Yes, yeah.
It'll tell you like how many guesses for, it'll actually subdivide your sequences up too. So if it's like, okay, well, this one I had to do a brute force on, but this area, this pattern, it was like, oh, that's an actual dictionary word. And so it's pretty slick. And so I think it's a good way,
Yeah.
just to kind of see what's happening with it. The project's on GitHub, so you can download the code and run it from the command line and check out, what's involved in it. One thing I was running in a REPL session, and I added imported pretty print because it outputs a big dictionary. It's way easier to look, to have it printed out with pprint.
Cool.
So make sure you import that too. So what you got?
The one I've got is one it's been on my radar for a long time, and it's because I'm a big fan of a YouTuber called Grant Sanderson, which goes by the YouTube handle of 3blue1brown.
Okay.
And his math videos are just they're really, he's such a good teacher, and he really does a great job of breaking down complicated subjects very simply and explaining things in very simple terms. And he's amassed quite the following on YouTube for that. For example, if you are into data science and you struggle with learning something like linear algebra, his videos on linear algebra are some of the best videos I've seen. And really, even when I took linear algebra in college, and then again I didn't really take a linear algebra class in graduate school, but when it came up in my abstract algebra, it was finally where some things clicked for me. I mean, it took years, where if you just watch Grant's videos, you'll get it in an hour. Basically, the stuff that took me years to finally.
That's a good
click.
Shortcut.
Yeah, the way he describes some stuff. But one of the hallmarks of his videos are these animations that he uses that are just beautiful. And it turns out that the way that he makes these animations is through a Python library that he created called Manim, or I believe it stands for Math Animation.
Okay.
Manim. And this library is interesting. You use Python scripts to create these little animations, and it's got a library that you import and create like a class that represents an animation, or really you import a class called scene, and then you subclass from that scene class to create different scenes in your animation. It's got some other tools in there to do stuff like fade outs and transformations and creating polygons and squares and circles and lines and all this kind of stuff. So it's got everything you need, and basically you just sort of map out, almost like a script, which is
okay. So you script it out.
But so it's like writing a script for like a play almost, where it's like, this is going to happen. Then here's your actors or the different kinds of shapes and everything, and then the things that they do, and then it's got some functions to play all that, and it actually outputs a video file. So you put all this together, and then it's got a command line tool that you use to run that script and generate a video file then that you can upload to YouTube or embed on a website or share with people. So it's just really neat. I mean, if you're into making mathematical type of animations, it's a fantastic teaching tool. It's a little bit, so the documentation is really lacking on this one. And there is no like official documentation that I could find very quickly, but there's a community, like a Discord community for it, that I think is pretty active. And there's also a tutorial that was written by a guy, I guess a fan of Manim, that kind of walks you through how to actually build some of this stuff. So it's sort of the missing documentation there for it. It's not complete.
Okay.
If you really wanted to master it, I think you'd have to just scroll through the source code and kind of pull some stuff out. But they are trying to work on that. And so if you're interested in contributing to open source software, that might be an area if you want to help document some of this stuff. But yeah, just a really cool project. One thing to note is that it has a lot of system requirements, things like FFmpeg, LaTeX.
Yeah, I was looking at that. Yeah.
Yeah. And so there is a way to run this using Docker, which I would say is probably a good way to do it if you're familiar with Docker and using Docker, just to avoid.
So they have a Docker image
Exactly. Yeah.
that has the stuff in it. Okay, cool.
So that you don't have to try to figure out how to get all these system dependencies working on your system. Just
yeah, they're very specific. So that's pretty important.
Yeah, exactly. But yeah, super cool project. And like I said, it makes beautiful animations. And I think that's one of the keys to Grant's success on YouTube is not only is a fantastic teacher, but the animations are just top notch. And so you can make your own animations using this Manim library.
Sweet.
Yeah.
That's very cool. Awesome. Thanks for coming on the show again and bringing all this stuff with you, all these articles to go over.
Yeah, absolutely. Love coming on the show.
All right. I'll talk to you soon.
Yep. See ya.
I want to thank David Amos for coming on the show this week and bringing along all those great articles. And I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.